Hello students, today we will see some of the last bits of the syllabus, and important among them is surge tank. Okay, see the diagram for a typical diagram for surge tank. Okay, so this is the reservoir. Okay, from here low pressure pipeline is there, and this pipeline goes to turbine, and a surge tank is installed in between. Okay, this section is called as penstoke, and this section is called as uh, low pressure pipeline. Okay, now you can see these levels. So this is the reservoir level, and in line to that, in horizontal, this is the static level of water in uh, in the surge tank. Okay, and this is EHF. Okay, so uh, head reduces due to friction between this pipe from here to here. Okay, so this is EHF, head loss HF, and this second dotted line indicates reduced head. Okay, the bottommost line represents uh, increased load line. That means when the load on the turbine is much increased, so water level falls down up to here. And this is topmost line is for reduced level, when the load on the turbine is reduced much, so water is stored in the surge tank. So this is plus Z. Okay, but we will talk about this later. Let us understand the diagram. This is the reservoir, pipeline, this is the turbine. Okay, and H is the total head difference between reservoir level and TWL, LWL and TWL, tail water level. Okay, length of pipeline considered is L here, because this is what we are going to design and talk about, L. Then velocity here is V, cross sectional area is A. Okay, and area of surge tank is AS. Okay, but before that, let us see some theory. Okay, so if electric power demand decreases suddenly, then load on turbine is also decreased. Water supply to turbine has to be reduced suddenly. Okay, so in this case, the water supply can be stopped by closing the valve at the end of penstoke. Okay, due to this rapid retardation of water in the pipeline, the water hammer effect may set up. Okay, when you close a water valve here suddenly, so water hammer can take place in this pipeline. Okay, to avoid water hammer effects, entire pipeline has to be designed to withstand high pressure. Okay, so this entire pipeline has to be designed for high pressure, as a high pressure pipeline, but this is costly. Okay, and that's why this surge tank is introduced in between. Okay, so if load on the turbine increase suddenly, then the supply of water to the turbine has to be increased suddenly. This is not possible if reservoir is far away from the powerhouse, or if the penstokes are of considerable length. Okay, now to tackle both these problems, the surge tank is introduced. So as a remedy for both the above stated problems, a surge tank is introduced. It is a sizable water storage uh, installed on uh, opening mode in the penstoke. Okay, it stores the water which is in excess of requirement of turbine, and it provides the extra water when it is suddenly required by the turbine. So this surge tank works as temporary water bank. It stores the excess water when there is a less demand, and it supplies the additional water when the demand is suddenly increased. So this is the surge tank. Okay, next, functions of a surge tank. So this needs to be seen in detail. Many times question is asked on this. Okay, so first, it reduces the high pressure created due to sudden closure of a valve. Thus it eliminates the possibility of water hammer phenomena in the penstoke. Okay, and thus uh, it saves the penstoke from possible bursting in case of water hammer. So the first important function of the surge tank is that it saves the penstoke